Hello students, in this video I'm going to discuss the conceptual differences between classical theory and quantum mechanics theory. Both theories are used in physics to explain matter and energy at different levels, but there are differences, fundamental differences how these theories operate. So, for example, the quantum mechanics is probabilistic in nature, while uh, classical mechanics assumes perfect determination. So, what do you mean by perfect determination? Determination means the physical properties of a system, of a classical system, have definite value at definite time. For example, suppose if I know the position of a classical system at a time t, and if I know the force acting on this particle, so then I can use the Newton equation on motion to calculate the position of particle at future time t's. That means I can know the trajectory of the particle following in future times. Similarly, because classical equations are time invariant, so if I know the present position, I can also predict its past position or past properties also. While in quantum mechanics, you don't know the present state of the system until you don't perform the experiment. After performing experiment, only you know what was the actual quantum state of the system. So in quantum mechanics is different in a way that only you know the possible outcomes. So which the possible result, so you can only calculate the probability of the possible outcome of possible result. So that is the main difference between these two theories. There are other differences like wave particle duality. So in classical mechanics, wave and particle are totally different entities, while quantum mechanics, it is not like that. So like small particles like electron, with them you can achieve the interference, which is the property generally associated with the waves. So small particle like electrons or even photons also can give you the wave effects. That is the main difference. So wave particle duality actually challenges the classical paradigm, and force us to think the exact nature of wave and particle. And now the third important property which we generally observe in quantum mechanics is the quantization. Quantization means the physical properties when you measure in quantum mechanics, they are not continuous like in classical mechanics. Classical mechanics, you can have a continuous energy values, continuous momentum values, angular momentum values. While when you do quantum mechanics, these physical quantities generally when you measure them in quantum system, they are discrete in nature. Like angular momentum is discrete, and energy is discrete. So this quantization is the main aspect which is associated with the quantum mechanics. Similarly, uncertainty principle. So like uh, physical observable like momentum and position and classical mechanics can be accurately measured simultaneously, while uncertainty principle says that physical properties, while measurement and the canonical quantities like position and momentum, energy and time cannot be measured simultaneously with high accuracy. So if you try to achieve accuracy in one quantity, other will be less precise. So that is limitation in measurement in quantum mechanics. The next aspect of or next property of quantum mechanics is superposition and entanglement. So superposition means a classical system in one can have only definite state, while quantum mechanics superposition principle is applicable. Superposition is applicable means a quantum system can have in multiple state at the same time. That So we can represent by them a superposition of many states. So superposition is very important property, because using this property, you can do fast calculations in quantum computers. Similarly, entanglement means if you do quantum systems, the state of one system can influence other system, regardless how far they are distant. So this is also very important phenomena which is used in quantum communication and quantum information processing. Then then about the measurement. When you do measurement, when you may do a measurement and classical system, it does not affect the system state. While it is not true in the quantum mechanics, when you do the measurement, the system collapses to the one of its possible result, or one of its possible outcome. So that is called eigenstate. So in quantum mechanics, the measurement affects the state. It is state also. Now, now the mathematical framework. There is a difference in the mathematical framework of classical mechanics and quantum mechanics. Classical mechanics, generally you use calculus. Of course, you use vectors also, but mainly you use calculus and differential equation. While while dealing with the quantum mechanics, you need a complex mathematical structure called Hilbert space. So mainly here, because the wave function or state are the element of Hilbert space, they live in Hilbert space. So you need to mainly use the mathematic tool of Hilbert space while manipulating or doing calculation with these wave functions. So in quantum mechanics, mainly we deal with the matrices, functions and operators. Operators. Of course, we use differential equation while using the Schrodinger when we work in the Schrodinger formulation. So, so that is the mathematical framework difference between these two theories. Now, about applicability, quantum systems give more resembles or more gives explanation of the quantum system, while classical theories mainly apply on our daily life, like on motion of a vehicle, celestial bodies. To understand the motion of celestial bodies, you cannot apply and the classical theory on the system, where you do directly or indirectly cannot sense, like happens in the quantum systems. So in the conclusion, there are different aspects where classical mechanics and quantum mechanics have differences. Like it is a deterministic. Classical mechanics is deterministic, while quantum mechanics is probabilistic. Quantum particle can behave like a wave as well as a particle, depending on the experimental conditions. While classical mechanics, wave and particles are two distinct entities. Quantization generally appears in only in quantum mechanics. Your physical properties have a discrete values, uncertainty principle, and superposition. Superposition is the main concept associated with quantum mechanics. And then about the measurement. When you do the measurement, classical system does not change the state. It does not affect the state of the system. While when you do the measurements in quantum mechanics, it changes the system collapses in one of his the possible, or in one of its eigenstates. So again, the scale, classical mechanics is generally applied on the macroscopic scale, while quantum mechanics is applicable to mainly atomic and subatomic particles. So these are the main conceptual differences or operating ways of these theories. So I'm stopping here. We will talk these conceptual differences in my next lecture again. So I'll stop here. Thank you very much.